Alright, this is the second part of the data analysis unit. Start with number 1. Danny created a box and whisker plot to display the number of laps around the track the boys ran in PE. Find the number of laps used to create the box and whisker, or explain why it's not possible to determine that from a box and whisker plot. So, it's not possible to determine because we're only given 5 pieces of information on this graph. We're given the lowest number of laps, the highest number of laps, the middle number of laps, which is the median, and the upper and lower quartiles. So, not possible. Only given min, max, the median, Q1, and Q3. Find the range of scores to create the box and whisker. Well, we do know that because we do know the highest and the lowest. So that's going to be 14 taken by 4. So the range is 10. Find the mode of the scores. Mode, we would need to know which score showed up the most. We don't know that, so explain why it's not possible to determine from the box and whisker plot. We don't have all of the data to see which score was most frequent. Number 2, Roger created this histogram, pieces of candy in a jar. Explain how to determine or why you cannot determine the number of pieces he used to create. So, all we have to do to figure out how many pieces of candy, add the frequencies. So the frequencies are 1 plus 4 plus 3 plus 2. All I'm doing is adding each of these heights. So that gives me 10. Explain how to determine the range. So again, range, we need to know the highest and the low. Can't see highest and lowest. We just know that the highest number is somewhere between 61 and 80 and the lowest number is between 1 and 20. Can you determine the median? We cannot determine the exact median, but we know the range. Since we know that there's 10 scores total, or 10 pieces of, let's see, 10 times that he counted the number of pieces of candy in the jar. So he counted it 10 times. The median is the middle score from a list. So all I have to do to figure out where it's going to be is figure out where the middle score should be. So if I've got 10 times we did something, divide that by 2, we get 5. So we go back up to the graph and we look for where our 5th count was. I've got 1, 2, 3, 4, 5. So my fifth count of the pieces of candy is somewhere in this section, which is 21 to 40. So the median is between 21 and 40. That's the best we can do. Number 3, the box and whisker shows men and women enrolled in psychology. Which data set has a greater median? About how much greater is the median of the data set? So the median is the middle value. This one appears to be 13.5 maybe, and this median is 21.5. So 13.5 to 21.5, that's about 8. That's the women. Women have a greater median by about 8 students. 4, which of the following is true about these two data sets? medians, ranges, means, and variances. So we don't know that. So we don't know that just by looking at the sets of data. So we're going to have to do some calculations with it. So I'm going to go over to my calculator and I'm going to put in the info 10, 11, 12, 12, 13, 14, 15. I'm going to do the same thing for the second list. 25, 26, 27, 28, 29, 29, and 30. And then with this calculator, we can actually, oh, I forgot to name them. Let's call this 1, we'll call it A, and B. And with this calculator, we can actually do both stat calculations at the same time. So we're going to do stat calculation, one variable statistics. There are two lists. So list 1 is A, list 2 is B, and we get all this information over here. So that X bar, that's our average, that's our mean. So are the means equal? 12.4 and 27.7. Nope, they're not equal, so C's out. The medians, if we scroll down a little bit, actually let's stop here. This weird looking O thingy, that's actually the standard deviation, which is the variance. And those are 1.59 and 1.67. Those are not equal. The medians and the ranges, I'm going to get that from this information here. We know that the range is the highest, which is max, minus the lowest, which is min. So for range, I've got 15 minus 10. So 15 minus 10, which is 5. And for the second one, I've got 30 minus 25, which is 5. So those are the same. Just to be sure, the medians are equal. Well, the medians are 12 and 28, so those are definitely not equal. So it is B. Number 5, another double box plot. What is the range for each store? So for Dillard's, it's the max is 80, the minimum is 25. And for Macy's, the max is 80, the min is 40. So for Macy's, it's 80 minus 40, which is 40. And for Dillard's, it's 80 minus 25, which is 55. So that's going to be A. 6. Identify the outlier in the data set. So for outlier, remember we have to do if it's a low number, that lowest number must be less than Q1 minus 1.5 times interquartile range, and the highest number must be greater than Q3 plus 1.5 times the interquartile range. So I'm going to have to go to my calculator, put this data set in, and then find Q1, Q3, and the interquartile range. So I'm going to make a new table, list and spreadsheet. We got 10, 11, 13, 30, 14, 15, 16, and 17. Menu, statistics, stat calculation, one variable statistics. We only have one list this time. That list is in our A. Press OK. Did something weird apparently. Min-max. Yeah, we're okay. So my minimum is 10. My max is 30. These are the only two values I have to check. And then Q1 is 12. Q3 is 16.5, and the IQR, that's the interquartile range, that's just going to be the difference between the Q1 and Q3, so that's going to be 4.5. So I'm going to check the low, I'm going to check the high, and then we're going to see what happens. So for the low value, we're going to check is 10 less than Q1 minus 1.5 times 4.5. And then separately, I'm going to check is 30 greater than 16.5 plus 1.5 times 4.5. So 12 minus 1.5 times 4.5 gives me 5.25. So we want to know is 10 less than 5.25. Obviously it's not. So 10 cannot be an outlier. And we check 30. So we're down here now. 16.5 plus 1.5 times 4.5. And I get 23.25. So we check is 30 bigger than 23.25. And that is true. So my outlier is 30 because that's too large. Does it affect the mean? Well, the mean is the average of all the numbers. So since I have an outlier that's too large for the data set, yeah, it's gonna, I remember I have to add up all the numbers to find the mean. And so when I add them all up, I'm adding a number that's bigger than it should be. So that's going to make the mean skewed higher. So does it affect the mean? Yes. Makes the mean too high. Does it affect the median? Well, the median is just the middle number. So whether that last number in the list is a 30 or a 29 or a 28 or a 23, it's not going to affect where, like, it's not going to affect the middle of the data set. So the outlier will not affect the median. Does it affect the mode? Nope, not going to affect the mode either, because the mode is just the number that shows up the most. So as long as that outlier does not show up the most, which it can't, because if it showed up the most, it wouldn't really be an outlier, because it would affect everything else. So the mode cannot affect, or the outlier cannot affect the mode. Finally, does it affect the range? Yes, because remember, range, we subtract the high and the low. So if the high is too high or if the low is too low, then it's going to make everything else off. 7. Average prices for 25 different airline tickets from Phoenix to California are shown. Make a dot plot of the data and explain what the distribution means. So it looks like the dot plot was already made for us, which is nice. And then the distribution. So we see things like skewed left, skewed right. Skewed means the whole thing is shifted left or right. So when I look at this data set, everything is shifted, like it's not centered. Everything is shifted to the left. So the data distribution is skewed to the left. More tickets cost less than the mean. So most tickets cost less than the mean. So that would be the correct answer. We can consider the median to be the middle. So the middle of our data set should be somewhere around here, because that's like the middle of all of our groups of data. But when I look, most of my ticket prices are left of that. So most tickets cost less than the mean. That is the correct answer. 8. The number of fans at a book signing on randomly 60 days is listed. Identify the outlier and describe how it affects the mean and standard deviation. Well, so outlier, once again, we are going to make a list. So control page plus, add a list. I'm going to put in all this data. I know it's in 3 rows. That's just so it wasn't some ugly table. We're just going to make one big list. 40, 22, okay, so there's my values. I'm going to menu, statistics, stat calculation, 1 variable stats, 1 list, it's A, and hit OK. I want to scroll back up. Here's all the information I need to know. So I've got a min of 5, a max of 2, or I'm sorry, a max of 40. So the only numbers I have to check are 5 and 40. So to check 5, that's a minimum value. So I want to know is 5 less than Q1, which in this case Q1 is 22, minus 1.5 times the interquartile range, which is 35 minus 22, gives me 13. And then the other number I would check would be 40. And when is 40 larger than Q3, which is 35, plus 1.5 times 13. So 22 minus 1.5 times 13 gives me 2.5. 5 less than 2.5, that is not true. 35 plus 1.5 times 13, which is 54.5, that is also not true. So there is no outlier in this problem. Does it affect the mean? No. In general, the outlier does affect the mean. And does it affect the standard deviation? Yeah, the standard deviation is the spread. It's how far apart the data is. And so if you have an outlier, it's spreading the data apart more. So yes, it does affect it. Alright, number 9. In high school, the students have a choice of pizza or hot lunch. Do more people prefer pizza or hot lunch? Do more people under 16 prefer pizza or hot lunch? So the total number of people that prefer pizza is 1750, and the total number of people that prefer hot lunch is 750. So more people in general prefer pizza. And then people under 16, so under 16, there's 500 that prefer hot lunch, 1,000 that prefer pizza, so that's still pizza. More people prefer pizza, however, more people under 16 prefer hot lunch. That is not true. More people prefer hot lunch. Also, more people under 16 prefer hot lunch. That is not true. More people prefer hot lunch. However, people under 16 prefer pizza. Not true. More people prefer pizza. Also, people under 16 prefer pizza. That is true. That is my solution. 10. The table shows the number of students participating in performing arts at a local school. How many juniors are in performing arts? So I'm looking at all juniors. That's all the way across, so there are 195. Which class is least preferred by seniors? So I look at my seniors, and I'm looking for the smallest one, which is that guy. So that's theater. And finally, which class is most preferred by juniors? So look at my juniors. I want to find the highest one. That's going to be right there, which is chorus.